You might be hearing this jargon or this buzzword a lot inside your project or inside some blogs or podcast or YouTube videos. So let's try to understand what are these cloud native applications and how they are related to the microservices. First, I'll try to provide a layman language like any non-technical person can understand these definitions. Cloud native applications are the software applications that are designed and developed specifically to leverage the cloud computing principles and take the full advantage of cloud native technologies and services, which means these applications are built and optimized to run inside any cloud environments by utilizing the cloud advantages like scalability, elasticity, and flexibility. In simple words, cloud native applications are built for cloud environments so that the organizations can take complete advantage of cloud provided services and technologies. Now let's try to understand the official definition of cloud native applications from the Cloud Native Computing Foundation. So if you see here, right now we are clear about the definition. Using Docker containers. These containers provide a lightweight and consistent environment for running applications and making them highly portable across different cloud platforms and infrastructure. With the help of these containers only, the code will work very similarly regardless of which cloud environment you're trying to deploy. You take this container, you try to deploy inside your local system, and you deploy inside the AWS, GCP, Azure cloud. In all the places, it is going to work in very similar manner. Whereas this is not the scenario with a monolithic application. Your monolithic application won't give such kind of flexibility. You need to put a lot of efforts to bring that consistency across all the cloud platforms. The next character of cloud native applications is they provide scalability and elasticity. Since you are building your applications based upon microservices and with the help of containers, they can be easily scaled horizontally, allowing them to handle any kind of traffic that comes towards your applications. So adding more instances of services is going to be super easy, and this can be achieved automatically with the help of container orchestration platforms like Kubernetes. We also have a separate section inside this course where I'll be showing you how automatically scale your microservice applications with the help of Kubernetes. Moving on to the next principle, these cloud native applications, they follow DevOps practices. By embracing all these DevOps principles, they promote a collaboration culture between the developments and operations teams. Whenever these cloud native applications are being built, there will not be any blame game between the developers and the operations team when they're building cloud native application, because they are following these DevOps practices. And with the help of these DevOps practices, they will incorporate continuous integration, continuous delivery, and automated deployment pipelines to streamline the software development and deployment process. So these cloud native applications, they will give complete flexibility to the organizations, whether they want to do continuous integration only, or whether they want to go with the continuous delivery, or if they want to go with the continuous deployment as well. The next character of native applications is they are resilient and fault tolerance in nature. Whatever applications that we are going to develop with the help of cloud native principles, they can withstand any kind of failures, which will make them resilient, and they will utilize techniques such as distributed architecture, load balancing, and automated fail recovery to ensure high availability and fault tolerance. One example that I can give here is, think like you have a microservice. By following the cloud native application principles, you will deploy this microservice in multiple locations. Even if one of the location has a downtime due to some power outage or due to some internet issue, the microservice will continue to work from the other location that you have deployed. And at the same time, for some reason, if one of your microservice instance is not working, platforms like Kubernetes, they can automatically shut down that microservice instance and bring up a new instance. This way, you are ensuring the failure recovery automatically and bringing fault tolerance inside your applications. Moving on to the next character of cloud native applications, which is they utilize cloud native services to a great extent. Like I said, cloud native applications means they are developed to leverage the cloud environments to a great extent. When an organization or an application uses these cloud native services, now inside this lecture, let me give a quick intro. Back in 2012, the engineering team at Heroku Cloud Platform, they introduced 12-factor methodology. So these are the 12 different development principles that are aimed at guiding the developers in designing and developing cloud native applications. These 12 different principles under the 12-factor methodology are the result of the Heroku team expertise from many years building these cloud native applications. When you follow these 12-factor methodology, your applications will have advantages like ready for cloud platform deployment. Regardless of whatever cloud platform that you choose, you can seamlessly deploy your cloud native applications. And at the core of these cloud native applications, they are going to support scalability and elasticity. And very similarly, these cloud native systems that you are going to develop with the help of 12-factor methodology, they allow system portability, which means your applications can run across Welcome back to the new section. Inside this section, we're going to discuss about that selecting a best option, and the same we are trying to implement inside the microservices like accounts, loans, and cards. Just a reminder, we are into the new section. That's why I have changed the background of the slide just to keep you engaged inside this challenge. Let me try to pose some questions to you. The very first question that I have for you is, inside microservices, how we are going to separate the configurations or properties from your business logic? Because without separating the configurations and properties from your microservices business logic, you cannot reuse the same Docker image across multiple environments. If you club all your business logic and configurations together, then for each environment, you need to create a separate Docker image along with the relevant properties or configurations. Since it is not a recommended approach like generating the Docker image again and again for each environment, we need to make sure we are using the same Docker image for all type of environments, including the production. With such requirements, how are we going to separate the configurations from the business logic? So this is the very first question that I have. In the similar lines, how we are going to inject the configurations or properties at runtime that are needed by our microservices during the startup of the service. Some of the sensitive properties like credentials, we can't mention them inside any configurations or inside any business logic. Such sensitive properties or configurations, we need to make sure we are injecting them into microservices during the startup of the service. In the very similar lines, whenever we're dealing with the configurations or management in microservices, we have multiple solutions available inside the Spring Boot ecosystem. And these solutions are like right from very basic solution, which is configuring Spring Boot itself with the relevant properties and the required profiles. And the second approach is applying external configuration with the Spring Boot. And the third approach is implementing a separate configuration server with the Spring Cloud Config Server project. So these are the options that we have. I'm going to show a demo of all these options. And in the same process, I will show what are the basic approaches. Inside this lecture, let me start with very basics on how configurations work inside any Spring Boot application. Because we are developing our microservices with the Spring Boot framework only. Inside Java ecosystem, to develop microservices, most of the developers and organizations, they are going to use Spring Boot framework. That's why we are also using the Spring Boot inside this course. Since we are using Spring Boot framework, first let's try to understand what are the options that Spring Boot framework is providing to handle the challenge of configuration management in microservices. Once we discuss these basic approaches, then we'll go to the advanced approaches that we have with the help of Spring Cloud Config Server. The main problem that right now we have is we want to externalize the properties for our microservices so that the same immutable code artifact can be used across different environments. So to handle these kind of scenarios, we are trying to learn how to separate the configurations and code base, and also how to externalize the configurations from the code base. So let's see if the Spring Boot is going to help us in externalizing our application properties. Spring Boot lets you externalize your configuration so that you can work with the same application code in different environments. You don't have to rebuild your application again and again. There are different approaches that Spring Boot lets you follow to externalize the configuration sources. And these approaches include with the help of property files and YAML files, where you can define all the required configurations and properties that your application or microservice need during the startup of the service. Apart from these property files and YAML files, we can also inject the configurations or properties during the startup of the service with the help of environment variables and the command line arguments. So there are many approaches. So let's try to understand in detail about them. By default, your Spring Boot application is going to look for the configurations or the properties that you have mentioned inside the application.properties or inside the application.yaml file. We're already using these inside our accounts, loans, and cards microservice, where we have defined various properties inside the application.yaml file, and we place that inside the class path location. Apart from these default name, we can also have other property file names, and we can make our Spring Boot to read from them during the startup of the application. But if you try to mention the properties or configurations inside your property file, you are clubbing everything along with the source code. So this approach may not work to a great extent. That's why Spring Boot also supports other ways to override the default values that you have defined inside the application.properties file. Maybe for development environment, you might have mentioned the default database credentials, but at runtime, inside your QA deployment or production deployment, we want to override the default values like username, password, URL details of database during the startup of the application. That's why to overcome this challenge, we can always override the properties with the other approaches like command line arguments, environment variables. So here you may have a question like, if I mention the same property in multiple locations, will there be any preference or the priority that Spring Boot follows? You can see here, these are all the most commonly used approaches to provide the configurations inside your Spring Boot applications. The very very first one is you can mention your properties inside the files like application.properties or application.yaml. So whatever you mention inside these files, they'll have the lowest priority or the lowest preference. If the same property is mentioned with the help of operating system environmental variables, then the previous value which is mentioned inside the application.properties will be overridden, and whatever value you have mentioned inside the environmental variables will be considered by the Spring Boot framework. And very similarly, you can also mention the configurations or properties with the approaches like Java system properties, JNDA attributes, servlet config init parameters, and command line arguments. The way the priority works is the lower items will be overriding the earlier ones, which means command line arguments is going to have highest priority, whereas the properties that you have mentioned inside the application.properties is going to have the lowest priority. So please remember this priority and the order followed by the Spring Boot framework, and this is going to be helpful for you inside your real projects. Now we understand Spring Boot allows us to externalize our configurations by following all these approaches, right from basic approach with the help of application.properties or YAML file to command line arguments. The next question that you may have here is, the properties are defined in some location or with some approach. How to read those properties inside my business logic? So let's try to understand the same here. Again, in Spring Boot, in order to read the properties, there are multiple approaches. I will try to present 3 commonly used approaches inside this course. The very first approach is with the help of @value annotation. So whenever you want to read a particular property, you can define a Java field inside your business logic. On top of that Java field, you can mention an annotation @value along with the what is a property key name. Once you mention what is a property key name with the format like you can see on the screen, during the startup of your application, Spring Boot is going to look for this property inside all the places like application.properties, environmental variables, and command line arguments. So if the same property is defined in multiple places, then definitely it will follow the order of priority, and accordingly it will populate the property value inside this field. Once we have the property value populated inside this field, you can use that anywhere inside your methods or inside your business logic. The next approach that we have is with the help of environment interface. Many times in real projects, many properties like sensitive information or sensitive credentials, they will be configured with the help of environmental variables. So the server admins, they will create these operating system environmental variables during the creation of the server very first time, or they might have created some scripts which will create the environmental variables during the creation of the server. So the same scripts they'll follow for all the servers. This way, any server that is coming inside your microservice network or the cloud native applications, they'll make sure that all of them, they have the same set of environmental variables along with the required values. So to read such environmental variables inside Spring Boot, there is an interface which is environment interface. So inside this environment interface, it provides many methods to access properties from the application's environment where your application is running. So wherever your application is running, inside that server, if there are any environment properties defined, those values you can access with the help of this environment interface. So wherever you want to read these environment properties inside your code, first you need to auto-write this environment interface to your class. Post that inside any method where you want to read the property, you can use getProperty method available inside this interface. And to this method, you need to pass what is the environment variable property name. I'll be showing all these in demo, so don't worry. For now, please note about all these approaches. The next approach that we have is with the help of @configuration properties. So if you see the very first and second approach, there are 2 drawbacks. The very first one is you are going to hard code your property key name inside your value annotation or inside your environment.getProperty method. And these methods, they are only useful to read a single property at a time. If you have multiple properties, then you need to define multiple Java fields with the help of @value. And similarly, you need to invoke these getProperty methods inside environment interface multiple times. So these 1 and 2 approaches we should use only if you have very few properties that we want to use. But if you have many properties configured for your application, then using this third approach is the most recommended approaches. This way, using this approach, you can avoid hard coding the property keys. So this approach is with the help of the annotation @configuration properties. How this approach is going to work is you need to define all your properties inside your property file with a prefix value. So once we define all your properties with the same prefix value, you need to use @configuration properties annotation on top of a Java class along with the what is the prefix value. Once we mention this annotation on top of a class, inside the class, you can create any number of fields along with the getters and setters. But please note that the field names and their return type has to be matched with what you have configured inside your application.property file or in any other location. I know it may not be very clear right now, but when I show you the demo of this third approach, it is going to be super clear for you. So with this approach, by the time the server started successfully, all your property values will be binded to the fields present inside the class myConfig. And to access all these fields, fields, you just need to invoke the get method available for all these fields. I hope you're clear about all these three approaches. From the next lecture, let's try to implement all these approaches inside our microservice. In the same process, we can also try to understand what are the disadvantages that we have with these basic approaches provided by the Spring Boot framework. Thank you, and I'll catch you in the next lecture. Bye. Now inside this lecture, let's try to update our microservices by defining some properties inside the application.yaml file and try to read them with the help of the approaches that we have discussed. Now inside this lecture, let me show you the demo of how to activate a specific profile using externalized configuration approaches. Since we are already using IDE, using this IDE also we can provide command line arguments, JVM arguments, and environment variables. We don't have to go with the approach to generate the jar first, post that, try to run the jar with the terminal. That approach can be used by the operations team and platforms team where they're trying to run the applications through the CI/CD tools like Jenkins, GitHub Actions. Since we are developers and we have the access to the IDE, let's try to utilize the same. First, let me show you the approach of command line arguments. To provide the command line arguments, go to your Spring Boot main class, which is accounts application. Right click on this class, and here you have an option which is modify run configuration. If you click on this and try to maximize this page, there is an text field where you can provide program arguments. Like we discussed, whenever we are trying to provide command line arguments, we need to make sure we are providing a prefix which is 2 hyphens. Post this, we need to mention the property which is spring.profiles.active. After this active, we need to mention what is the profile that we want to activate. Right now inside the application.yaml, we have activated the QA profile. This time, let's try to activate the prod profile using this externalized configuration. Along with this, I'll also try to override the value presence inside the build.version. For the same, I need to mention 2 hyphens. Post that, I need to mention build.version is equal to, I'm going to mention some 1.1 as a value. Now we need to click on this apply OK. Now you can stop your application and try to start the application again. This time, the application should have started with the production profile. So let's confirm the same. Inside my Postman, I'm trying to invoke this contact info API. You can see I'm getting the message which has prod APIs. And at the same time, the contact details name has product owner details and the relevant mobile numbers. Now let's go and test the build info. Here, ideally, we should get 1.0 since we have activated the prod profile. But on top of that, we also overrided the value defined inside the profile with the help of command line arguments. That's why if I try to invoke this, you can see I'm getting the value 1.1. So this is the one approach on how to provide the configurations using an externalized approach. Now let's try to use the next approach, which is JVM system variables. For the same, I need to go again to the accounts applications and click on these modify run configurations. This time I'm going to remove my command line arguments. Here by default, you'll not be able to see the option to provide the JVM system variables. To make it visible here, we need to click on this modify options. And here there is an option which is add VM options. If you click on this, you can see you got a new text field which has VM options. Here we can paste the same values like we did for command line arguments, but we need to make sure instead of double hyphens, we need to mention -d and what is a property value like spring.profiles.active is equal to prod. And the same I have to do for the next property, which is -d build.version is equal to, this time I'll mention something like 1.3. So with this, let me click on this apply and click on OK. Now I'll try to restart my application again. So I'm trying to start my application in debug mode. I'll go to the Postman. So first, let me click on this contact info. You can see the prod profile is activated. So we have mentioned the QA profile inside the application.yaml file. Now we can test the build info. Here we should get the output as 1.3, and this is working perfectly fine. Now let's test the last approach that we have, which is with the help of environment variables. For this approach also, we can right click on this accounts application and click on this modify run configurations. Now here, first, I'm going to delete the VM arguments. Post that, you can see there is an environment variables option. Here, first I can paste the values. Now I can remove these -d, and the same I can do for build.version. There is no need of any prefix, but please make sure all the environment variables are separated with semicolon value. Apart from this, we should also make sure we are mentioning all the values in uppercase letters. Post that, we need to replace dot with underscore. The same let me do for profiles. After this, I'm going to replace the dot with underscore. Now I'm going to make this active as uppercase value. Let me do the same for build version also. So I'll just convert this to uppercase and replace this dot with underscore and mention version in all capital letters. So here, this time I'll try to override this build hyphen version to a new value, which is 1.8. So let me apply these changes and click on OK. I will stop my application and I'll try to start again in debug or run mode. So let me go to the Postman. We should be able to see the prod profile is activated. The same is confirmed by looking at these message content and the name under the contact details. Now let's go to the build info. We should get the value 1.8. So we're getting 1.8 value. As a next step, what we can do is we can try to provide this build.version property in all the approaches. So for the same, I'll stop my application first and I'll right click on this accounts application. And here I'll click on this modifier and configurations. We already have build underscore version under the environment variables. Now under the program arguments also, which is like command line arguments approach, we can mention build.version, but please make sure we need to mention 2 hyphens. And very similarly, I'll also try to mention the build.version under the VM options. So here, what I'm going to do is I'm going to mention VM options with a different value, like maybe I'll mention 1.1 and mention the prefix, which is -d. So as per our understanding, command line arguments has highest preference. So that's why now the output should be 1.3, where anyway we are activating the Spring Profiles active is equal to prod inside this environment variables. So let's try to focus on build.version. So I'm clicking on this apply, post that, clicking on this OK and starting my application in debug mode. So what is the output that we should get right now? We should get the output, which is 1.3. So I'm just trying to send this build info. You can see I'm getting 1.3. As a next step, I'll go to accounts application again and clicking on this modifier and configurations. This time I will remove the command line arguments. With that, now the fight will be between the JVM system variables and the environment variables. And in these two, the highest preference goes to the JVM system variables. That's why we will get the output as 1.1. So let's try to confirm the same. I'm trying to restart my application in a debug mode. Now I'll go to the Postman. We should get an output, which is 1.1. You can see we are getting the output 1.1. I can stop my application. I'll right click on this accounts application, click on this modifier and configurations. Now I will remove these JVM system variables. With that, obviously, whatever build version we have mentioned under the environment variables will come as an output. Now, if I try to remove the value even here also, the value that we have defined inside the production profile will come into picture. So let's confirm the same. I'm trying to click on apply and OK. Post that, I'm going to start my application in debug mode. So now the output should be 1.0. I'm trying to test this build info API. You can see we are getting 1.0 as an output. This way, we are able to solve most of our problems. We built different profiles inside our application, and we are able to activate the profiles through externalized configurations. And at the same time, if needed, we can override the existing property or we can provide a new property through externalized configurations. And this way, we can make our microservices immutable, and the same Docker image we can deploy in multiple environments without the need of regenerating Docker image again and again. So this solves the problem that we have. But do you think this is the best approach and we can follow this? Of course, this may work to some extent. You will be seeing some projects or some organizations using this Spring Boot profiles concept and externalize the configuration concept to maintain their properties inside the microservices environment. But these may work to some extent. And this is the most basic approach to maintain the configurations inside the microservices or cloud native application. This basic approach will not work. This approach has some good amount of disadvantages. I'll try to explain those disadvantages in the coming lectures. But before we try to discuss them, first let's try to make the similar set of changes inside the loans and cards microservices as well. I hope you are excited for the assignment. Let me introduce this assignment in the next lecture. Thank you, and I'll catch you in the next lecture. Bye. As of now, we have updated the accounts microservice with the concepts like Spring Boot profiles, and we have introduced many properties inside the application.yaml file, and we read the same properties by 3 different REST APIs inside accounts microservice. Now I'm going to give you an assignment. Are you ready for the assignment? The assignment is you need to make very similar changes inside cards and loans microservice. And this is going to be super easy. If you have questions like what is the property name, what is the property values that I have to use, please refer the code present inside the GitHub repo. If you see inside the GitHub repo, EasyBytes/microservice project, under this repo, there is a section 6, and inside this, I have uploaded the folder, which is v1-spring boot. Under this version 1 Spring Boot folder, we have 3 different microservices. Accounts we already completed. If you have any questions around cards, what type of properties we have to use, like I said, please use the same properties like we created for accounts microservice, but try to give different phone numbers, different contact details, and different message. So you can also get those details by going into this GitHub repo and look at the application.yaml file. And if you have any questions, you can always refer to the code present inside this GitHub repo and complete the assignment. My sincere request is to complete this assignment so that you are getting enough hands-on. I'm trying to explain with one microservice, and if you do the similar changes inside the 2 microservice, that is going to bring a lot of practice for you, and these concepts will be entered into your subconscious memory. So even if someone is trying to take an interview by waking you up in the midnight, you will be able to answer all the questions because you are doing a lot of practice inside this course. So please put an effort here and try to implement the changes inside the other microservices. If you face with some issues, don't get demotivated. Anyway, I'm going to cover the code changes inside the cards and loans microservice very quickly inside the next lecture. I hope you'll be successful at this assignment. Thank you, and I'll catch you in the next lecture. Bye. Okay, I'm assuming you are successful at the assignment. If not, don't worry. Anyway, I'm going to cover all the code changes inside the cards and loans microservice right now inside this lecture. First, let's go to the loans microservice. Like we know, first, we need to go to the loans controller class. So let me go to the loans controller class. First, I have done the changes related to the auto wiring of this environment and local contact info DTO, which I have created. On top of that, I'm trying to read the build.version property with the help of @value. And similarly, I have created a new constructor inside the loans controller, and I'm trying to inject this property, which is iLoanService. After making these initial auto wiring related changes, I have created 3 different APIs towards the end. Like you can see, the first API is related to the build info, which will give the response what build version we are trying to use right now with the help of this Java variable build version. And accordingly, I have mentioned this operation and API responses details as well, which will be useful for the REST API documentation with the Swagger UI. Now moving on to the next API, which will help us to read the Java home environment variable. And the API path is very similar to accounts microservice Java-version. Very similarly, at last we have contact info API, where we are trying to read all the properties that defined inside the application.yaml by populating into the object of loans contact info DTO. So let's try to see what is present inside this loans contact info DTO. So here, since inside the application.yaml, we are going to have a prefix as loans for loans microservice, we need to make sure we are using the same. After that, everything is going to be same, like it is going to be a record class, and it is going to accept different fields like message, contact details, and on-call support by following the data type based upon the properties that we have defined inside the application.yaml. Now to activate these configuration properties inside the loans application class, we need to make sure we are mentioning this annotation, which is @enable configuration properties. And to this, make sure we are passing the DTO class of loans contact info DTO. If you go to the resources folder, I have created 2 new YAML files, which is application_prod and application_qa.yaml file. First, inside the application.yaml, we have the properties related to the loans microservice, like build version, loans message, loans contact details, and loans on-call support. I just try to keep everything same except the values of this message, contact details, and on-call support. Post that, we need to import the new config files that we have created, which is application QA and application prod YAML. And as of now, you can see I'm trying to activate a profile QA by hard coding the value inside the application.yaml file. Now let's go and validate the application_prod.yaml. You can see I'm mentioning to the Spring Boot framework to consider this whenever someone is trying to activate a profile prod. And you can see I have the build version and other properties which has prefix as loans. The same kind of setup is present inside the application_qa.yaml. So these are the changes that we need to do inside the loans microservice. Most of the changes are very similar to accounts microservice. Now let's try to test these APIs. For the same, I'm going to the loans application and starting the application in debug mode. Now inside the Postman, under the loans folder, you have the APIs like build info, Java version, and contact info. So first, let me try to invoke this build info. So I'm trying to invoke this. Since right now the QA profile is activated, we should get the output 2.0. So this is working fine. The Java version anyway will come based upon the Java home path setup inside my local system. So that is what coming inside the output. Now going to the contact info, here we'll get the details from the QA profile. Like you can see, this is the message from the QA profile, and these are the contact details and on-call support details in the QA profile. Now let's try to quickly try to activate a profile of production using externalized configuration. For the same, I'm going to stop this server and right click on the loans application, select this modify run configurations and maximize this. Here, I'm going to mention the property which is --pring dot profiles dot active is equal to prod. I'm just trying to activate the prod profile. So let me apply these changes and click on OK and start the application again in debug mode. Now we should get the response from the production profile properties. I'm just trying to invoke this contact info. You can see I'm getting the prod related properties inside the response. The same you can confirm with the build info where we'll get the 1.0 as an output. With this, all the loans related APIs are working perfectly. Now let me stop this application and try to show you what I have done inside the cards microservice. Inside the cards microservices also, it's the same story. First, you'll go to the cards controller. Inside the cards controller, first you will do all the auto wiring and dependency injection related changes at the top of the class. Post that, you're going to create 3 different REST APIs. The very first one, which is going to return the build information based upon the build version Java variable, followed by the API, which is going to return the environment variable with the name Java_home. And at last, we have the contact info REST API, which is going to return all the details defined inside this object cards info DTO. So this DTO is also a record class. Please make sure this has a prefix as cards. Post that, you'll go to the cards application and you'll mention this enable configuration properties annotation along with the cards contact info DTO class. After making all these changes, the next set of changes are inside the application.yaml and application_prod.yaml and application_qa.yaml. So once you have defined all these details, you can start your application in debug mode. So let me try to start this in debug mode. First, we'll see by default the QA profile is activated because inside the application.yaml file, we right now activated the profile QA. So let me go to the Postman. Here under the cards folder, you can see there are APIs like build info. First, I'll try to invoke this. You'll get 2.0 like expected. Java version, it is going to work like expected. Coming to the contact info, you're going to get the details from the QA profile. Let's try to activate the prod profile by using command line arguments. For the same, first, let me stop this server. Now I'll right click on this cards application and select this modify run configurations. Post that, I'm going to mention the command line arguments with the prefix --, followed by pring.profiles.active is equal to prod. So let me apply these changes and start the application again. So I'm going to the Postman now to validate the changes. Here I'm trying to invoke this contact info API. You can see I'm getting the properties from the prod profile. The same you can observe for the build info where you'll get the 1.0 as an output. This way we have done all the required changes in all the 3 microservices like accounts, cards, and loans. If you have any questions, please refer to the GitHub repo. Please make sure all your changes are very similar to like we discussed. And please be very careful with these application.yaml files. Even if you try to mess up with some space, your profiles will not get activated. For example, instead of these profiles under the Spring parent, if you try to provide one more space, that will take these inside the config parent. With that, your profile will never get activated because you have mentioned in a wrong location. That's why this spacing is very important inside the YAML file. I hope you are super clear, but like I said, this is not the best approach. This is the most basic approach that any microservice application can use. For organizations where they are going to build hundreds of microservices, this approach may not work. It has some serious disadvantages. So let's try to understand what are those disadvantages in the next lecture. Thank you, and I'll catch you in the next lecture. Bye. Inside this lecture, let me show you the limitations or the drawbacks that we may face when we try to externalize the configurations using Spring Boot framework alone. The very first drawback is we try to externalize the configurations using the approaches like CLI arguments, JVM properties, and environment variables. They are effective ways to externalize the configurations. I do agree with that. And they also support to maintain the immutability of your application build. You don't have to regenerate your Docker image again and again for different environments. Until this point, everything is perfect. Now, coming to the disadvantages, like we saw, whenever we are trying to use these approaches, it often involves executing separate commands with the help of Java commands or manually setting up the application, which means we need to inject these CLI arguments, JVM properties, environment variables manually at some point of time, like maybe inside the CI/CD pipelines. So this process again may introduce potential errors during the deployment. And again, you can see you need to dependent on someone, like there should be some human setting up all these externalized configurations during the startup of the application. And doing that for all instances, for all the microservices is going to be super challenging. So you can automate most of these tasks with the help of CI/CD pipelines like GitHub Actions or Jenkins. But still, there is a chance that someone can mess up this process. So that's the very first limitation that we have here. The next limitation is if you have hundreds of microservices, then you'll also have thousands of configuration properties that will evolve and changes on day-to-day basis. So just like how your application code, you should also follow the strategies to store and maintain the versioning of your configurations and properties based upon a release. And at the same time, you should also support the auditing functionality, like who accessed your configuration, which clients accessed your configuration data. With the Spring Boot profiles alone, we are putting all our configurations inside the source code itself. So anyone who has access to my source code or Docker image, they can easily understand all my configurations, and it is not a wise decision to expose all the configurations to anyone. That's why it is always recommended to store our configuration separately inside a centralized repository where it supports all kind of versioning, tracking, revision, and auditing the configurations. Right now, Spring Boot and profiles cannot provide this advantage. That's why we can call this as a limitation. And whenever we are trying to use environment variables, they lack granular access. Like whoever has access to your production server, like all the server admins, they can see your environment variables. Maybe you're trying to configure database credentials or some sensitive properties with the help of environment variables because you don't want to mention them inside the application.yaml file or inside the profile files directly, since that is going to expose your sensitive information to everyone. But even if you try to follow the environment variables, with this approach also, your server admins will be seeing your environment variables. That's why this is considered as a serious security limitation. Inside the microservices, we will deploy multiple instances of a single microservice. Like we have 3 microservices like accounts, loans, and cards. But if we decided to deploy 3 instances of each microservice, then there'll be total 9 Docker containers or total 9 instances will be running inside your production. In such scenarios, providing all these externalized configurations with the CLI arguments, JVM properties, or any other approach is going to be super challenging. And here I'm just talking about 3 microservices where each one has 3 instances. Think like 100 microservices where each one has at least 5 instances. Then the number of instances are going to run inside your production is going to be 500 instances. You can imagine, even if you have a single manual task involved for a microservice, the same has to be repeated in all the microservices. That's why this approach is not going to work when you're trying to deploy multiple instances of your microservices. The next limitation is around the security. Think like you want to provide the database password to your Spring Boot container. In the previous lectures, we discussed on how to manage configurations inside the microservices with the Spring Boot alone. And when we follow Spring Boot alone to maintain the configurations, we have a lot of limitations and drawbacks, which we discussed in the previous lecture. Now, inside this lecture, let me try to introduce a better option or the recommended approach that you need to use inside any organization where they are building hundreds of microservices. This option is by using the Spring Cloud Config. Inside the Spring ecosystem, there is a project with the name Spring Cloud Config just to handle the configurations inside any cloud native systems like microservices or any cloud applications that you are trying to build. In this approach, we are going to have a centralized configuration server, which means we need to build a separate application that is going to act as a configuration server with the help of Spring Cloud Config. Using this centralized configuration server, we can overcome all the limitations and drawback that we discussed in the previous slide. And whenever we are using this approach, your centralized configuration server is going to provide server and client-side support for externalized configurations in a distributed system like microservices, which means all your individual microservice, they can register as a client with this Spring Cloud Config server, and this Spring Cloud Config server can act as a centralized configuration server. It will be more clear when we start implementing these inside our microservices. For now, please note that this configuration server, which we are going to build with the help of Spring Cloud Config, it is going to act as a central place to manage all your external properties or configurations for all your microservices across all the environment. The centralized config server that we are going to build with the help of Spring Cloud Config revolves around 2 core elements. The very first one is you are free to store all your configurations or property files inside any location, like you can store inside a GitHub repo or inside a file system or inside a database. You choose a location where you want to store all your configurations and properties securely. Once you store all your properties or configurations, then this configuration server is going to oversee the configuration data within the data store, facilitating its management and distributing to multiple applications like microservices. So let's try to understand more details about these 2 core elements. Like I said in the very first step, you can save all your configurations and properties inside a centralized repositories. And this repository can be a database or a GitHub repo or a file system or inside your class path. And there are many other options that Spring Cloud Config Server supports to store your configuration properties. I'll be showing all those options by looking at the official documentation of Spring Cloud Config Server. So once we store all these configuration properties inside a centralized repository, as a next step, you're going to create a configuration server with the help of Spring Cloud Config. And this is going to load all the configurations by connecting to your centralized repository. So now your config server holds the properties of all the microservices and environments. Now, as a next step, our individual microservices, they can connect with this config server as a config clients, and they can load the configurations during the startup by connecting to this configuration service. So this is how it is going to work. Like you can see, there are 3 microservices like loans, accounts, and cards. All of them during the startup, they will connect to this centralized configuration server. This way, we are delegating all our properties and configurations to an externalized location, and all our microservices, they are going to read these properties during the startup based upon the profile that is activated. Apart from supporting all the features of Spring Boot, this config server also overcome all the limitations that we have discussed in the previous lecture. So let me show you more details about this project inside the Spring official website. This is the official website, which is spring.io. Here you can hover on these projects and click on the Spring Cloud. Under the Spring Cloud, there are many other sub projects that will help you various challenges while you are building cloud applications or cloud native applications or microservices. Right now, we are looking for the Spring Cloud Config. So you can click on the Spring Cloud Config. And this is the project that will help you to build a centralized config server that is going to provide server and client-side support for all your externalized configuration in a distributed system. I'm assuming you're at least getting some sense what is the purpose of this Spring Cloud Config. Don't worry if something is not clear. When we start implementing these inside our microservices applications, then it is going to make more sense to you. Now, before I try to close this lecture, let me give a quick introduction about this Spring Cloud project inside the Spring ecosystem. Like I said before, this Spring Cloud provides various frameworks or projects for developers to quickly build some of the most common patterns of microservices or any other cloud native applications. For example, we already saw Spring Cloud Config is one such framework or project available inside the Spring Cloud, which is going to help us to overcome the challenge or to implement a common pattern, which is maintaining the configurations inside the microservices environment. Very similarly, Spring Cloud also has various other projects, which is going to help us to overcome the challenges and implement common patterns like service registration and service discovery, routing and tracing, load balancing, Spring Cloud security, distributed tracing, and messaging. These are the most commonly used projects inside the Spring Cloud. But apart from these, there are many other projects available inside Spring Cloud. Inside this section, we are going to focus more on Spring Cloud Config, since right now we are focusing more on the configuration management. But please note that we are going to use majority of the projects available inside the Spring Cloud inside this course to overcome the challenges and implement common patterns inside our microservices. So this is a very quick introduction I want to give about Spring Cloud. This Spring Cloud is different from Spring Boot. I hope you are clear. From the next lecture, let's start the journey of Spring Cloud Config. Thank you, and I'll catch you in the next lecture. Bye. Inside this lecture, let's try to create a separate config server with the help of Spring Cloud Config. For the same, as of now, inside the section 6 folder, we have a subfolder with the name v1-spring boot. And inside this, we have all the 3 microservices with the name accounts, cards, and loans. And inside these microservices, we handle the configuration management with the help of Spring Boot alone. Now we are trying to move to a more advanced option. And in the process, I have to delete a lot of code inside these microservices, especially the configuration related files. That's why I don't want to make the changes related to the Spring Cloud config inside this v1-spring boot. Instead, I'm going to create one more folder indicating the version 2. So let me try to copy this folder and paste it inside the same folder. Post that, I will just rename this to v2. v2 indicates version 2 spring cloud config. This way you will have references for both type of changes. One is with the help of Spring Boot and the other one is with the help of Spring Cloud config. So inside this folder, if you go and try to look for the hidden folders, you'll see a folder with the name .idea, which is created and maintained by your IntelliJ IDEA. I want to delete this because this belongs to the previous workspace that we have opened. So now we have created a new folder with the name v2-spring-cloud-config. And inside this folder, we can start making all the changes related to the config server. So first, I want to create a new config server. For the same, let me go to the start.spring.io website. First, I'll make sure that the language is Java and the project type is Maven. Post that, I'm fine with whatever version right now we have, which is 3.1.2. Like I said before, always go with the latest stable version. I will be updating the code inside the GitHub repo every quarter to the most recent version. Now, I want to mention the group details. The group details will be com.easybytes. Post that, the artifact ID that I want to mention is config server. Since we are trying to build a config server for our microservices network, I want to mention this name, which is config server. The same I want to consider under the name as well. Now coming to the description, I'll just mention something like config server for Easy Bank Microservices. So once we mention this description, I'm fine with these package names. So please make sure you are giving the same details also so that your code and my code always look similar, and that will help you to identify any mismatches easily. So the packaging should be jar. Coming to the dependencies, the very first dependency that we want to add here is config server. So just look for config. If you try to see regarding configurations, we have two types of dependencies. One is config server and the other one is config client. Whenever we are trying to build a centralized configuration server, we need to make sure we are selecting the dependency which is config server. You can also see the description, central management for configurations via Git, SVN or HashiCorp Vault or any other approaches. Whereas config client you should use whenever you are trying to connect your microservice with the config server. So inside your individual microservices like accounts, loans and cards, you need to add this dependency which is config client. For now, I'm going to select this config server since we are trying to build the configuration server. Post this, I want to add one more dependency which is actuator. So Spring Boot actuator, like we discussed, it is going to support to monitor and manage our applications such as application health, metrics, session, etc. So please add this dependency as well. After adding these dependencies, you can try to click on this explore button, which will show you the pom.xml. So you can see this is the Spring Boot version and this is the group ID, artifact ID, versions, and the description. Everything is matching with what we have given. And the dependencies, we have actuator, config server. And by default, we'll get Spring Boot starter set for all kind of Spring Boot projects. Here, the important information that I want you to observe is there is a Spring Cloud version mentioned, and this version is 2022.0.3, whereas the Spring Boot version is 3.1.2. Why we have complete different version numbers for Spring Boot and Spring Cloud? The reason is Spring Boot and Spring Cloud are two different projects inside the Spring ecosystem. They'll have their own version numbers. So when you try to create a Spring Boot project from the start.spring.io, the automatic mapping of the Spring Boot version to the Spring Cloud version will happen automatically inside this website. And it is also going to add a dependency to add these Spring Cloud related dependencies along with the version that we have defined inside the top, which is 2022.0.3. Here you may have a question like, what if I'm not using the start.spring.io to create a Spring Boot project? Maybe you're trying to add the Spring Cloud related dependencies to an existing Spring Boot project. In such scenarios, you can go to the Spring Cloud website. On this page, they have mentioned the Spring Boot release train along with the Spring Boot compatibility versions. So you can see for all the Spring Boot versions which are starting with 3.0 and 3.1, we should use as 2022.0.3. Whereas for the older versions, very similar way, they have mentioned all the Spring Cloud versions. So using this release mapping between Spring Cloud and Spring Boot, you should be able to easily identify the Spring Cloud version. And here I want to share you a fun fact. If you see all these Spring Cloud versions, they have a name like Dalston, Edgware, Finchley, Greenwich, Hoxton, Ilford, Jubilee, and Kilburn. Do you know how these names are derived? If you are from London, you should be easily identify these names. So all these names are derived from the substations or metro stations inside the London city. You can see they're also following an order like D, E, F, G, H, I, J, K. So this is a fun fact that I came to know. If you are from London, please enjoy this fun fact. And for others, it is still a good information to know about it. Now we can go to the start.spring.io and click on this close button, and I can click on this generate button. This will download a new project into your local with the name config server. So let me copy the config server project into our workspace. So I'm into the folder which is v2-spring cloud config, and here we have only 3 microservices. Now I'm going to paste the new project that we have generated with the name config server. So let me double click on this and extract this folder. So the extraction is completed. Now I can remove this .zip package that I have. Now, as a next step, I'll go to my IntelliJ IDEA and open this folder, which is v2-spring cloud config. So here I'm just clicking on this open. I'll go to storage, workspaces, microservices, section 6. And inside this, we have folder, which is v2-spring cloud config. So this will create a new workspace inside this folder. Make sure you are loading all the Maven projects by clicking on this load button. So from now onwards, you're going to have 4 different Maven projects like accounts, cards, config server, and loans. Now, as a next step, let's go to the config server and open the main class that we have, which is config server application. Here we need to mention an annotation to enable the config server functionality. And the annotation is @enable config server. So this is the annotation. Once we mention this annotation, we should be good. As a next step, let's go to the application.properties inside this Spring Boot project, which is config server. So as of now, you can see we have application.properties, but like you know, we are following the YAML configuration inside this course. That's why I'm going to rename this to application.yaml so that we can start using the YAML configuration. So let me open this application.yaml. As of now, it is an empty file. The very first configuration that I want to mention here is server port. So I will mention the port value as 8071. So throughout this course for config server, we are going to use a port 8071. So please make sure you are also following the same. Otherwise, you need to make lot many changes in lot many places throughout this course. So once we make these changes, we have the config server ready inside our microservices network. But as of now, there is no place for my config server to read the configurations. That's why we need to move all the required configurations of our microservices to a centralized location, and we need to configure that centralized location inside this config server so that our config server will start reading from the centralized location. And there are multiple options that we have when we try to store all our configurations inside a centralized location, right from class path to file system, GitHub repository, database, and at the same time, we can also store inside the cloud like AWS S3. So there are many options, but inside this course, I'm going to cover 3 different approaches, which are like very common. The very first one is we'll store all the configurations of the microservices inside the class path of the config server. And the second approach is we can store inside a file system. When I say file system, you can store anywhere inside your server or inside your local system, and you can read the configurations from the particular folder inside your file system. And the third approach, which is the most commonly used, is with the help of GitHub. So let's try to discuss all these approaches one by one. I hope you are excited about these approaches. Thank you, and I'll catch you in the next lecture. Bye. Inside this lecture, let's try to store all the configurations of our microservices inside the class path of our config server. Before I try to make those changes, first let me try to define a new property inside the application.yaml of config server. And this property is Spring, and under the Spring, we need to invoke application. After the application, we need to invoke name. So I'm trying to set a name for my config server. So whenever we're trying to set a name for our Spring Boot application, we can use this spring.application.name property, or you can also follow this YAML configuration inside your Spring Boot applications. So the name that I want to give here is config server itself. So please make sure you are giving a space after the colon, and the name is config server. So from now onwards, for all our Spring Boot applications, we are going to give the name for them. Using these names only, the entire Spring Cloud config server concept is going to work. More details to follow. For now, we just assigned a name for our Spring Boot application, and the name is config server. Now I'll go to the resources folder, and inside this resources folder, I'm going to create a new folder with the name config, because inside this config folder only, I'm going to store all the configurations related to other microservices. First, I'll try to get the configurations from the accounts microservice. Under this, we have 3 different profiles like default, prod, and QA. So let me try to copy these 3 values to the config server location. So under this config directory, I'm trying to paste all these 3 new files. So here you can see we have 3 different files. But here there is a challenge for our config server. Like for accounts microservice, we can mention these 3 files. If you try to bring the files of cards microservice and loans microservice or any other microservice, they are all going to have the same name. So that will create a lot of confusion to config server, like which files it has to load, which properties it has to load during the startup. To overcome this challenge, all our property files, we should name them with our Spring Boot application name or with the microservice name itself. For accounts, I'm going to set the spring.application.name as accounts in few minutes. That's why we can change the name of this application.yaml to accounts.yaml. Very similarly, I will do the same for other file as well. Here, I'll just remove the application and mention accounts, and with that, the file name will be accounts_prod.yaml. Since we are using this application_prod.yaml inside the accounts.yaml, it is asking, do we need to change the name inside the application.yaml also? So we can click on this do refactor. That should be fine. Now, very similarly, I'm going to rename the file name of application_QA. So the file name is going to be accounts_QA. I'm going to click on this refactor and do refactor, and with this, we have the 3 different files of accounts microservice, which are representing 3 different profiles. If you see under the accounts_QA, as of now, we have these properties. Of course, we need them because these are the properties that we are trying to externalize from our business logic. Here, I don't need this property because I'm not going to use the approaches related to the Spring Boot. Since we are going to leverage Spring Cloud config, we can safely delete these property. With that, right now, we have only the properties related to the build version and accounts microservice like message, contact details, and on-call support. So let me do the same for accounts_prod also. Here also, I'm going to delete this. And very similarly, I'll go to accounts.yaml. And all these are the properties related to the accounts microservice. And we don't want to externalize all these server.port, H2 database related properties. So that's why we can delete this. And we don't need to mention all the file names with the help of this spring.config.import. That's why I'm going to remove these configurations as well. With this, inside the config server, we have strictly the properties or the configurations for default profile, for prod profile, and similarly for QA profile. I'm going to do the same for loans and cards microservice as well. So behind the scenes, I'll make them and I'll come back in few seconds. I successfully created the property files related to cards and loans microservice, you can see there are 6 new files that I have created under this config folder. And these files have the microservice at the application's name itself, like cards and loans. So we follow the same naming convention. If you can try to open any of this YAML file under this cards.yaml, we have all the properties or the configurations of cards microservice that we need to follow in the default or local profile. Very similarly, if you can open randomly loans-prod.yaml, here we have all the properties related to loans microservice that needs to be activated whenever we're trying to activate the prod profile. So now we have moved all the required properties into the centralized location, which is inside the class path location of my config server itself. I have to communicate to my Spring Cloud config server that I have stored all these files in so and so location. For the same, we need to open the application.yaml of Spring Cloud config server. Here we need to create a few configurations or properties. The very first one is spring.profiles.active. So we already have Spring here. So just under the Spring, I can try to mention a new element, which is profiles. After these profiles, I'm going to mention a child element, which is active. Under this active, we need to mention a value, which is native. So with this native, I'm trying to tell to my Spring Cloud config server that I want to activate a native profile of Spring Cloud config server. So whenever we are trying to use a class path to store all our configurations, we need to make sure we are activating this native profile. Once we define these profile activation details, now under the same Spring, we need to create few more properties like spring.cloud. Under the cloud config, after the config, we need to mention server. And after the server, we need to mention native because we activated the native profile. Under the native, we need to mention search locations like search-locations. With this property only, we are going to tell to the Spring Cloud config server where our properties are stored. Right now, our properties are stored inside the class path. That's why we need to give this class path prefix followed by colon. And post that, we need to give the folder location inside your class path, which is config. So with this, we should be good. We have made all the required changes. Now let me save these changes and do a build. Since we are trying to do the build very first time inside this workspace, it is trying to ask me to enable this annotation processing, which is required for Lombok. So let me try to enable this and post that. I'm going to do the build again. Now I will try to start my Spring Cloud config server in a debug mode, and this will start my Spring Boot application at the port 8071. You can see this is the port number. Now the server is started successfully. How to validate if the server loaded all the properties from my storage location? For the same, we can try to invoke various get API paths that are exposed by the config server. So here we need to invoke the path, which is localhost 8071 / and what is the microservice name or application name that you want to check for the properties. So first, let's try to check for accounts, and inside accounts, multiple profiles like prod, QA, default. So here, if you try to invoke the URL, which is localhost 8071 accounts prod, you should get the properties related to the prod profile of accounts microservice. So let's try to access the same. So as of now, you can see I'm getting the properties from the default profile from this file, which is accounts.yaml. Seems there is an issue with my accounts microservice. So let's try to see what is the issue. I made a mistake, which is like I have used underscore, whereas we should use hyphen. I have used the same hyphen for cards and loans, but for accounts microservice, I made a mistake here. So please allow me to correct this issue. So I'm going to rename this property file name to accounts-prod. So please don't use underscore. We should use the hyphen. So let me try to rename the QA as well. You can see a single character is creating such a major issue inside the application. So now we should be good. Let me restart the application after doing a build. So I'm just stopping my application and trying to start the application again. So here I'll try to access the account/prod. You can see